Hello everyone, in this video we're going to solve 2025 AB Precalculus free response question 3. For a guitar to make a sound, the strings need to vibrate or move up and down or back and forth in a motion that can be modeled by a periodic function. At time t equals 0 seconds, point S on one vibrating guitar string starts at its highest position, 2 millimeters above its resting position. Then it passes through its resting position and moves to its lowest position, 2 millimeters below the resting position. Point S then passes through its resting position and returns to 2 millimeters above the resting position. This motion occurs 200 times in 1 second. The sinusoidal function h models how far point S is from its resting position in millimeters as a function of time t in seconds. A positive value of h of t indicates the point is above the resting position. A negative value of h of t indicates the point is below the resting position. So this information is extremely important. The graph of the function h and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated and no axes are represented. Determine the possible coordinates of t, h of t for the 5 points F, G, J, K, and P. Alright, so we look at this one right here. Go ahead, sketch the guitar, right? So suppose I have the guitar like this. Alright, so this one is the resting position. Now when it's go up here, it's gonna be 2 millimeter. When it's go down here, it's gonna be negative 2 millimeter, right? Look at this one right here, it say that, right? And negative values is below the resting position, right? Positive is above, right? So you have the maximum is 2, you put 2 right here. Minimum is negative 2, so the midline should be 0, right? Now, after you have the y coordinate of this point, you put this guy over here. This guy must be 2. This guy must be 2. This guy right here must be 0. This guy right here must be 0, right? And this guy right here must be negative 2, right? Now you need to fill in the x coordinate, right? So we look at this one right here. We need to find the period first, right? So the period equal time divided by number of rotation, right? So it's gonna be 1 second right here divided by 200. 1 divided by 200, right? Now, after you have period, you need to take the period divided by 4 to find the length of each quarter, right? So 1 over 200 divided by 4. It's gonna be 1 over 800. This is the length of each quarter, right? So look at this one right here at time t equals 0. Point S is on the vibrating guitar string start at its highest position. Alright, so highest position is right here. Right, so t equals 0 is going to be right here. So the point F has the coordinate 0, 2. Now, each quarter you keep adding 1 over 800, right? So I have 1 over 800 right here, right? This one should be 2 over 800, right? This one should be 3 over 800, and this guy should be 4 over 800, right? Now, if you want to simplify, go ahead simplify. If you don't want to, leave it like that, that's fine, right? So I just leave it like that. Now, question B. The function h can be written in the form h of t equal a sine b t plus c plus d. Find the values a, b, c, and d, right? Now, we know that a is the amplitude. It could be maximum subtract minimum divided by 2. So it could be 2 subtract negative 2 divided by 2, right? So it could be 2, right? Now I need to find the midline. It could be maximum plus minimum divided by 2. So it could be 2 plus negative 2 divided by 2. So it could be 0, right? Now I need to find b. It could be 2 pi divided by period. It could be 1 over 200, right? So I need to multiply the top and bottom by 200, right? So it could be this one cancel out. We have 400 pi, right? And the last one, c. We need to determine the phase shift, right? So you know that the sine function always starts from the midline, right? So it could be like this, right? So if it's going up first, a should be positive, right? Second one right here is going down. So this one a is negative, right? Now you're gonna pick the phase shift. You can start right here, right here, right here, or right here, right? So I just pick 2 points right here, which is given right here. So it have saved my time, right? Now if I pick the point G, so which means it shift to the right 1 over 800, which means c equals negative 1 over 800, right? And then the function is going down first, right? Which means a is negative, right? So right here c equals negative 1 over 800, and then a right here must be negative 2, right? Now the second option is I still have a equals 2, right? D equals 0, b equals 400, right? Now see, if I pick the starting point right here, which means the function shift to the right 3 over 800, so c equals negative 3 over 800, and the function going up, right? So a positive, right? So a still the same, right? This one negative 3 over 800, right? Let's move on to question C. Refer to the graph of h in part A. The t-coordinate upon g is t1. T-coordinate upon j is t2. Right? So point G and point J is going to be this guy right here. On the interval t1, t2, which of the following is true about the function h, right? Now, in order to know if the function h is positive or negative, look at the y-coordinate. The y-coordinate right here is less than 0. You see that 0 and negative 2 less than 0, right? So the function must be negative, right? So I need to eliminate a and b. Now the function is going down, which means it's decreasing, right? So the answer must be D. Let's move on to question C2i. On the interval t1, t2, describe the concavity of the function h and determine whether the rate of change of the function h is increasing or decreasing, right? So within this interval, the function is concave up, right? And the rate of change is increasing because the function is concave up, right? Alright, so here's the answer for question C2i, and it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.